Today we're talking about two-dimensional figures. You might also see these referred to as being 2D. The D stands for dimensional. So we're going to be dealing mostly this year with things that are polygons. So we're going to make ourselves a nice little T-chart, and we're going to draw some pictures. And so on the left of our T-chart we're going to have polygons, and on the right we're going to have things that are not polygons, just so we can make sure we know what a polygon is. Okay? And so on the polygon side, a polygon has to be made up of straight lines, and it has to be a closed figure. And it can be made up of as many straight sides as you would like it to be, but it does have to be made up with straight sides. So we're interested in things like triangles and squares and rectangles. We're also interested in things like pentagons and hexagons. Okay, oops. And then, fun shapes like this that you may or may not have a name for at this point, but are closed figures and are made up of straight lines. And I apologize, some of these lines don't look quite as straight on the iPad as they would if we could draw them with a ruler on paper. They have to have straight lines. Okay? Let's talk about things that are not polygons. Polygons have to be just one shape. So you wouldn't have something like this. This is not a polygon because this is really like two shapes combined. Shapes like this are not polygons because they are not closed, right? They look like they have an opening here. Things like ovals and circles are not polygons because they are not made up of straight lines. And things like this are not polygons because they have a line that extends out here beyond the actual shape. Okay, so that's going to be really important. When we get to talking about polygons and we're comparing polygons, we like to be able to group them. And so we have polygons that are convex, and we have polygons that are concave. So this would be a separate T-chart from the one before, and everything we draw in here will be a polygon. Okay, so we take all the polygons we talked about before, and we're going to split them up into two categories. Okay, and so when we're talking about concave polygons, if you were to extend the sides, okay, of the polygon in any direction, none of those lines would go inside the shape. So for example, your standard triangles, okay, if I extend these sides, right, they go on and on and on forever on the outside, they're never going to pass through the interior of this triangle. Okay, so this would be convex. Other shapes that are convex include things like squares. Okay, same reason. If I extend these sides, okay, they'll go on and on and on forever, but they're never going to cross over the interior or into the interior of the square. So no lines cross in here. Okay. On the other hand, if I take something like this, which I think of as a like the little Star Trek lapel pin, they're communicators. If you look at them like this, you'll notice that if I were to draw some of the lines, they stay on the outside, right? So at first I'm thinking, ooh, maybe this is in the wrong category. But then I get to these two here on the bottom, and notice how this line sticks out here into the inside of this shape. Oh, see, that means that it has a line that's on the inside. Okay, and that means that it is concave. I also like to think of it as it's going to look like one part of the shape is caving in. So if one vertex looks like it's pointing in towards the center of the shape, like this one is here, then that means it looks like it's caving in, and so it's concave. Okay. Another example of a concave polygon would be, let's see, something like this. And again, let me make sure all my corners line up here. And so again, if I were to draw this line here or this line here, you'll notice that they start to cross into the interior of the shape here. That means that they are concave. Or you can look and you can see, oh, this vertex here, it looks like it's going to the center of the shape. That means it looks like it's caving in. And so that makes it concave. Okay. When we want to name our polygons, we are going to name it based on the number of sides, which goes back a little bit to the way that, or the name polygon in the first place, which means many angles. And you're going to notice the number of sides and the number of angles are going to be the same. So you could name it by either one. So the first 12 of those are listed in your book, right? And you'll notice like 3 sides is going to be called a triangle. And remember, our prefix there means 3, our prefix tri means 3. 4 is going to be a quadrilateral. And remember that the prefix quad means 4. And so on and so forth. You will need to memorize those first 12, okay? And it's not really 12, it's really 9, because you can't have a 1 or a 2-sided closed figure that's made up of straight sides. It's not possible. So you're really just learning 3 through 12, and most of those you're going to be really familiar with. So I really think you might have to learn 4 or 5 new ones. Anything that's over that 12, okay? So up through 12 you have a name. Anything over 12 is going to be an n gon, and you are going to replace this n with whatever number of sides. So I'm going to make me a note here. Replace with the number of sides. Okay. So for example, if I have a figure that has 13 sides, okay, it would be a 13 gon. You just write it 13 dash gon. If I had a shape that had 50 sides, okay, it would be a 50 gon. Okay, so after 12, they really get quite a bit easier in my opinion. We have 2 more things we're going to look at with these. The first is going to be if we're talking about something that is equilateral. Equilateral. If we break this down, equi means equal, okay, and lateral means sides. So something that is equilateral has equal sides, meaning all the sides are congruent. Okay? So this means all sides are congruent. Okay? And most of you are pretty familiar with an equilateral triangle where all the sides are the same. Okay? If we have something that is called equiangular, okay, we'll break that down. Equi means equal. Angular means angles. And so this would mean that all the angles are the same. And that means they have the same measurement. Right, so they are congruent. And one of the things you may not know is that if you have an equilateral triangle where all the sides are the same, then you also have an equiangular triangle where all these angles are the same as well. Okay? If you have any polygon, whether it's a triangle or something else, where they are equiangular and equilateral, so equiangular and equilateral. So all the sides are the same length, they're congruent, all the angles are the same. Then that means that that is and it's a polygon, it means it is a regular polygon. Okay. So that's all of our new terminology for this section that we're going to be using over and over again. We are going to be looking at some formulas that you've seen before, including perimeter and area. So if you want to look over those before class, they are on page 58. And we'll go over those in class tomorrow. And thank you very much for watching. I hope you have a lovely evening. Goodbye.